Welcome back, everybody. This is our sixth class in JEE Mains previous year questions for chapter Moving Charges and Magnetism. Before this video, in this series, we have made 5 videos for this chapter, and all of those videos are available on our YouTube channel's playlist section. We have also started similar series for NEET previous years. So, if some of your friends are preparing for neat, then you can guide them through that playlist. It might be helpful then. If you find these videos useful, then do press the like button, share them, and subscribe to our channel. Also, if you want to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount, however small it may be, will be highly appreciated. With this, let's start today's video. In the previous one, I think we completed up to 40 or something. This was the last question, 41, and today we will go to start with 42. So find the magnetic field at a point P due to a straight line segment AB. AB is a straight line segment of length 6 centimeter carrying current of 5 ampere. It is carrying a current of 5 ampere. So first of all, if we analyze all the options, we have not been asked regarding direction. We have been only asked regarding magnitude, and that we can find out easily using formula for magnetic field by a lone conductor, and that is formula is mu naught I by 4 pi t sine of phi 1 plus sine of phi 2. This is the base formula which we have. And here AB is the conductor, P is the point at which we have to find out. So this will be the value of phi 1 and this will be the value of phi 2. Suppose we have a middle point here, suppose C. Now in triangle ABP, this is angle. AC is, we can say, our perpendicular, and AP is hypotenuse. So CP, that is base, and we can easily find out sine phi 1 in this one. Sine phi will be perpendicular by hypotenuse. Perpendicular AC is 3 centimeter because total AB is 6. So sine phi will be 3 by 5. Sine phi 1. Similarly, in the second triangle BCP, sine phi 2 will be again 3 by 5. So sine phi 2 is also 3 by 5. Putting these values here, so magnetic field will be mu naught is 4 pi into 10 raised to power minus 7. Current is 5 and 4 pi distance. The distance is CP. This is perpendicular distance. Perpendicular distance is here CP, and that is 4 centimeter. So 4 into 10 raised to power minus 2. Sine phi 1, it will be 3 by 5 plus sine phi 2, 3 by 5. So in total 6 by 5. So 4 pi get cancelled. This 5 get cancelled. And from these two, we have 3 by 2 into 10 raised to power minus 5. And that is 1.5 into 10 raised to power minus 5 Tesla. Option B will be the right answer. Moving to the next one. The magnitude of the magnetic field at the center of an equilateral triangle loop of side 1 meter, which is carrying a current of 10 ampere. So here we have a, we can say, equilateral triangle forming a loop. Means current is flowing in a closed loop, or current is flowing something like this. Let me draw the triangle first. Suppose this is our triangle. So here current is flowing in the closed loop. So in this arm, suppose current is, if we consider current is flowing in anti-clockwise, so here it will be this and here it will be this. Means current is flowing in closed loop. A, B, C. So we have to find magnetic field due to these three conductors, conductor AB, conductor BC and conductor CA at the center of the equilateral triangle. So we will have center here. And at this center, what we will have? This center has a property that if we pass a line from one of the corners to this center, through the center, then what happens? Then this line is first of all is perpendicular bisector of this AB, and it also bisects this angle into two equal parts. We can do similarly for AC or for the corner A. And why we are doing this? Because we have to find these angles. Suppose we are going to find magnetic field due to AC conductor, then we have to find the angle phi 1 and angle phi 2. And let's also do for the part BC. It will go something like this. So I think video got stuck somewhere between. So I'm redesigning. So let's first join these points. Now these red lines act as a perpendicular bisectors for the opposite sides and also act as a bisector for the angles. So we can say from here that length of AC is equal to, as per given, that is 1 meter, and here if we say ABC and this is D, then length of AD is equal to 0.5 meter. Now this whole angle BAC is equal to 60 degree because it is an equilateral triangle. So angle BAC is equal to 60 degree, and this red line is dividing it into two equal parts. So this side will be 30 degree and this side will be 30 degree. Now coming to here at point D, as this is a perpendicular bisector, so this angle will be 90 and remaining angle will be 60 degree, and again this angle will be 60 degree. Now writing formula for magnetic field for for conductor AC. So for conductor AC, magnetic field will be mu naught I by 4 pi d sine of phi 1 plus sine of phi 2. So we have value of mu naught 4 pi I, sine phi 1 and phi 2 we solved already. So what we have left with to solve, that is distance B. Suppose this center is point O. So we have to find distance OD, and that we can find out using in triangle OAD. OAD, in this triangle we know that value of base is AD, that is 0.5, and we have to find the perpendicular OD. So perpendicular by base is tangent theta, so perpendicular is OD. So OD by base, that is 0.5, is equal to tangent of 30. So from this OD comes out to be 0.5 by root 3, or we can say it is 1 by root 2 3. So now we have all the values for conductor AC. Now we can put these values here. So mu naught is 4 pi into 10 raised to power minus 7. Current is 10 ampere divided by 4 pi divided by distance 1 by root 2 3. So it comes 1 by 2 root 3. Sine phi 1 yani sine 60 Sine 60 is root 3 by 2. So root 3 by 2 plus root 3 by 2. 4 pi get cancelled. Here we have 10 raised to power minus 6 into 2 root 3. And from here we have further root 3. So root 3 into root 3, 3 into 2, 6. So 6 into 10 raised to power minus 6. This is the magnetic field due to a single AC conductor. Now coming to the AB conductor, value of magnetic field will be same. We just have to notice the direction. Applying right hand screw rule, as current is going upward here, at the center field will be coming out of the screen in the plus K direction. For conductor AB, again as current is going downward, so field will be coming upward. And for same for the conductor BC, as current is going in the right direction, so field at point O will be coming out of the screen. So magnetic total field at point O is coming out of the screen and is a vector sum of magnetic field due to all these three conductors. And as all these three conductors are identical and are at same distance, so value of magnetic fields will be same, and we can say total field will be 3 times of this value. So 3 into 6 into 10 raised to power minus 6. So it will be 18 into 10 raised to power minus 6 Tesla, and it is 18 micro Tesla, and it will be in positive K direction. If we assume current to be counterclockwise, if we assume it to be clockwise, then it will be in minus Z direction. Moving to the next one. A square loop is carrying a steady current I, and the magnitude of magnetic dipole moment is M. If the square loop is changed to circular loop and it carries the same current, magnitude of magnetic dipole moment of the circular loop will be. Now we know that formula for magnetic dipole moment M is I into A. Now initially we have a square loop. So its magnetic moment is given small m is equal to current times its area. Suppose its side is a side of square is equal to a. So area will be a square. Now we deform or we transform this square into a circular loop. So what will happen? This was our square and we deformed it or transformed into a square. So there is a quantity which will stay constant, and that is perimeter. The perimeter of this square will be equal to circumference of this square. So we can say 4 of A is equal to 2 pi of R, where R is the radius of this square. And from this, radius of square comes out to be 2a by pi. Now as this circle has the same current as mentioned in the square, so magnetic moment for this circle will be I, current is same, times area, and area will be pi r square. So pi and square of this term 4a square by pi, and we can write it like this: 4 divided by pi, or square, there is square, so square get cancelled, so 4 by pi into I a square. So 4 by pi as it is, and I a square is equal to small m. So that's how option D will be the right answer, and we can see that magnetic moment has been increased. Now coming to the next question. So as shown in the figure, two infinitely long, so let me slide it down slightly. Two infinitely long identical wires are bent by 90 degree and placed in such a way that the segments LP and QM are along the x-axis while PES and PQN are along the y-axis. If OP is equal to OQ, this distance OP and OQ is equal to 4 centimeter, and the magnitude of magnetic field at O magnitude is 10 raised to power minus 4 Tesla, and the two wires carry equal current, so current is equal I in both. The magnitude of the current in each wire and the direction of magnetic field at O will be, two wires carry equal current. Okay, so we have to find out magnitude of the current and we have to find out direction of the magnetic field. So first of all, let's find out the direction so that uh, we can rule out some options out of these fours ABCD. Now here we will have four components of magnetic field. First will be magnetic field due to this LP part or LP conductor. Then magnetic field due to PS conductor. And assuming these are infinite distance conductors. Plus then magnetic field due to QM conductor. And magnetic field due to QN conductor part. And we know that as conductor LP and conductor MQ, these are, or we can say point O is a axial point. Point O is axial point for LP and MQ. So at point O, due to LP and MQ, magnetic field will be 0. So BLP is equal to PQN is equal to 0. Now coming to the remaining two. So our total field will be reduced to magnetic field due to PS plus magnetic field due to QN. Now applying the right hand screw rule, as in the PS, current is going upward. Current is going upward. So magnetic field on the right side. On PS we have two sides, on the left side and on the right side. Magnetic field on the right side will be going into the page. So it will be in minus K or negative Z direction. And for QN, for this conductor, current is going downward, and using right hand screw rule, we can easily find out that magnetic field on its left side will be going into the page or again in minus K. So here total field will be going into the page and not out of the page. So here option A per out of page and option B out of page both get cancelled, and we have only C and D. I think D is missing here. In D we have 40 ampere perpendicular into the page. So we have only now two options for the current. Now let's find out the value of magnetic field due to each of these conductor. And we know that for a conductor magnetic field value is mu naught I 4 pi d sine of phi 1 plus sine of phi 2. That's the value of magnetic field for a conductor. Now let's start for the conductor PS. For conductor PS, we can see that if we have to form two angles here, those two angles will look like that. First angle will be formed from the P point and second angle will be formed from the point S. As S is at infinite distance, so this angle will be approximately 90 degree, and point P is just at the point bisector point, so this angle will be 0 degree. In actual reality, when we have a conductor and we have a bisector point here, then we form angles such like this. This is our phi 1 and this is our phi 2. Now in this case, our this point, is lying here. So this angle is almost 0 and this point is at infinite distance. So this angle is almost 90 degree. So this whole equation will reduce to mu naught I by 4 pi d sine phi 1, that is 90, so 1, plus sine 0, that is 0. So magnetic field due to PS conductor will be mu naught I by 4 pi d, and similarly for the magnetic field for the QN conductor, applying the same criteria, it will be again mu naught I by 4 pi d, and both of these magnetic fields are in same direction, so they will be added, and our total magnetic field will become twice of mu naught I by 4 pi d, and its value is given equal to 10 raised to power minus 4 Tesla. Now putting these values, so mu naught 4 pi into 10 raised to power minus 7 I as it is, divided by 4 pi into distance, that is 4 centimeter in statement already given, is equal to 10 raised to power minus 4. 4 pi get cancelled, this 4 get cancelled on 2, so we have here 10 raised to power minus 5 into I divided by 2 is equal to 10 raised to power minus 4. We can write like this: I is equal to 2 into 10 raised to power minus 4 by 10 raised to power minus 5, and solving this we will have 20 ampere. So option C will be the right answer, and field is into the page. Moving to the next one. The current loop having two circular arcs joined by two radial lines as shown in the figure. It carries current of 10 ampere. Magnetic field at point O will be close to. So we have to find magnetic field at point O, and again, as already done in the previous question, here magnetic field will be due to four conductors or four parts. First will be due to PQ, then due to PS, and then due to SR, and then due to RQ. Now this PS is a arc, so it is a part of circle, and RQ is also a part of circle, it is an arc. So here we will use magnetic field due to a circle, and PQ and SR are straight conductors. So for them we will use magnetic field due to parallel straight conductor. Now as we can see that PQ point O for PQ and for RS is a axial point, means this point O lies on axis of PQ and on axis of RS, so their magnetic field will be 0, and we have we have only contribution from PS and from RQ only, and as these are a part of circle, so we can say closed loop, and for a closed loop magnetic field is mu naught I by 2R. Now what we can do here, as this is the magnetic field due to a complete loop, but we have only a portion of loop here, and that portion is only up to 45 degree. So here magnetic field will be 45 degree out of 360 degree, or we can say we have taken 45 degree part out of 360 degree, as we have only contribution from the 45 degree part. So magnetic field will become, and for both this angle is 45, so formula will stay the same, only current and radius and direction will change. So we can write it like, it will go on 9 Okay, on 15. So 3, 2, 4, and 8. So it will be mu node I by 16 R. Now let's start with magnetic field due to PS. So magnetic field due to PS will be mu node into I, that is 10 by 16, and the radius, that is 3 plus 2 5 centimeters. So 5 into 10 raised to power minus 2. And we also have to notice the direction, as here current is flowing from uh, right to left. Using right hand screw rule, we can say at point O, magnetic field due to this current will be inward into the page, or will we can say in minus k direction. So it will become, final answer is mu naught, it will on 2 and it will on 8. So mu naught by 8 into 100, and that can be written as 25 by 2, 25 by 2 with minus k sign. Now for magnetic field for R Q or QR, so it will be again mu naught, value of current is same, that is 10, and we have 16 here, and radius is 3. So 3 into 10 raised to power minus 2. So here we can note, so this will go on the top, and it will be mu naught into 10 raised to power 3, so 1000 divided by 48. And we also have to notice here direction. For current flowing from left to right, if we find magnetic field using right hand screw rule, here direction of magnetic field will be out of the page, or we can say plus k. So we can cut it further. This will be on 500, 24, 250, 12, 125, 6. So 125 by 6 mu naught times k. And as we have to add these two, so we make their denominator same. We multiply this by 6 or 3. So it can be written as 75 by 6 mu naught minus k. So total magnetic field will be, total will be, this is positive part and this is negative part. So 125 by 6 mu naught k minus 75 by 6 mu naught k, and subtracting these we will get 50 by 6 into mu naught, that is 4 pi into 10 raised to power minus 7 with k sign. And I think we can solve it further. It will go on 3, and this will become 2 pi, and approximating, as this is pi is approximately equal to 3, so we will be left with 50 into 200, pi get cancelled with 3, we are just approximating here. So 50 into 200 into 10 raised to power minus 7, so 10 raised to power minus 5 approximately. And our answer matches with option D. Now let's move to the next one. So here we have one of the two identical conducting wires of length L is bent to form a circular loop, and another is bent to form a circular coil of n identical turns. If the same current is passed through both, the ratio of magnetic field at the center of the loop to the center of the coil will be. So we have to solve this for two conditions, one for the coil and one for the, you can say, loop. So here we will solve for the loop, and here we will solve for the coil. As length of wire is same for both, so suppose in case of loop the radius is RL And in case of coil, we have radius RC, and we have also n turns in coil, because invention. In coil, we have also n identical turns, and length is L. So for loop, we can say we have only single turn, and circumference of this loop should be equal to the length. So we can say L is equal to 2 pi r L, and from this radius of the loop is L by 2 pi. For the coil, we have n turns, each of radius RC. So total circumference, that will be equal to n times 2 pi RC, and that is equal to length of the wire, that is L. So from this RC, radius of the coil is L by 2 pi n. Now we have to find the magnetic field, as current is same in both of these. If current is same, then magnetic field due to loop is, we can say, BL. Magnetic field due to loop is mu node I by twice of the radius of the loop. So mu node I twice L by 2 pi to get cancelled, and we are left with mu node pi I by L. Now here, in case of this, magnetic field due to one turn of the coil. Here we have n turns, and radius of one turn is this. So magnetic field due to one turn of the coil, magnetic field due to one turn of the coil will be mu node I by twice of the radius, and radius is L by 2 pi n. To get cancelled, and we will be left with mu node pi n I divided by L, and this is due to one turn. As we have n turns, so total magnetic field will be BC, will be n times of this value, so it will become n square mu node pi I by L. So now we can divide BL by BC will be equal to mu node pi I by L n square mu node pi I divided by L. L get cancelled, mu node pi I get cancelled, and we are left with 1 by n square. Means magnetic field in case of coil is stronger as compared to magnetic field in case of loop, and option D will be the right answer here. Now let's move to the next one. Dipole moment of a circular loop carrying current I is M, and magnetic field at the center of the loop is B1. When the dipole moment is doubled by keeping the current constant, the magnetic field at the center of the loop B2 is B2, then the ratio B1 and B2. So as mentioned, that we have a dipole moment of a circular loop. So dipole moment will be I into area, or we can say I current into pi r square. And magnetic field B1 at the center of this loop, having magnetic moment M, magnetic dipole moment, it will be mu node times I by twice of R. Now it is mentioned that dipole moment is doubled by keeping the current constant. So if we double this value and keeping the current constant, means radius has to be changed. So our new dipole moment is twice of the m, and current is as it is same. So pi times radius has changed. Radius becomes r dash. Putting value of m here, so 2 I pi r square is equal to I pi r dash square. I and pi get cancelled, or we can say r dash is root 2 times of the original radius. Now using this radius, new radius, we can find out new magnetic field at the center. So B2 will be mu node I by twice of the new radius, and that is root 2 times R. We can take 1 by root 2 out, mu node I by 2R, and that is equal to original field. So B2 is equal to B1 by root 2, and from this B1 by B2 is equal to root 2. Option C will be the right answer here. So with this, we end this video here. Hopefully whatever we have covered in this video is helpful to you again somehow. And if you find this video useful, then do press the like button, share it as much possible, and subscribe to our channel. If you have any doubts or suggestions, put them in comment section. I will try to implement. And also, if you like to support us, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any help will be highly appreciated. With this, again, thanks for watching, and we will meet in next video.